Hello, James. Well, welcome today. This is the first day of the Programming Foundations class that you've gotten in as my top student. Um, I'll go over the high level stuff and then I don't know if you have a mic. Of course, you can chat as well if you don't have a mic or camera. I can turn that on if you want at some point if you have any questions. But let me go over the high level. I see you've already made some good progress through some of the material. So hopefully if you hadn't already previously had experience in programming, the little bit we gave you in the system admin on scripting kind of give you a kickstart into this stuff. This is, of course, a Python class. And so the first thing that they show you how to do is set up VS Code and set up the Python system itself. And so what I was going to do is actually, I'm not going to set up VS Code on this machine because I don't need it. I have it set up on another machine. But that one is actually pretty straightforward. I am going to share a screen and I'll take you through a few things. And so let's minimize some stuff out of my way here. So the first thing, which I'm sure, hello, how you doing? You've already done most of this, haven't you, right? Got VS Code set up and the Python all good to go?
Yeah, I'm on lesson 3.
Cool, great. Well, I'm just going to run through real fast so I can put it on here and maybe we can show some other stuff and also to put it in the video for any future person watching it later when it's not just us. But I appreciate you showing up. I'm going to go ahead and download that. And then, actually, I should be in my download folder. So I don't have Python on this machine, so I'm going to go ahead and just run the install real quick for that, which is a fairly fast, relatively speaking, given everything going on. We'll install the typical for all users, give permission, of course, all that good stuff. Just to kind of, while that's running through install, I'll try to go through real quick some of the stuff you've already done, and if there's anything new for you or value there, great, and if not, we'll just have it in the recording. But in lesson 1, mainly the big part was setting up the VS Code and the Python and those extensions. Then we play a little bit with the command interpreter at the command line, which you can do at the command shell or at the PowerShell command line on Windows or at the terminal if you're on Mac. And then they talk a little bit about strings, using single or double quotes, of course, around your strings. They show a few methods, which is interesting that we start with some methods. This is one of the classes I didn't build. It's already in the system. But nonetheless, they talk about methods without really defining them. Methods are just functions that are part of objects. And so we'll get to that later when we get to object-oriented programming. And then they just sort of talk about the various data types. Python is what's called a dynamically typed language, so you don't have to define like that a variable is going to be a particular type. You can just set up a variable and sort of automagically Python will figure it out. But it supports strings if you put them in quotes or single quotes. It supports integers, which are basically whole numbers without any decimal or remainder. Float numbers or anything with a point, whatever, any kind of value. And then they go on and talk about, of course, some of the basic flow control like if and if else, and we'll look at some of those, as well as, of course, keywords. And they even talk about the various naming conventions. A lot of people just do everything lowercase code. Some people do things in uppercase. Some people do it in camel case, where they up the first letter, or what's called mixed case, where the first is lower, but then the rest of the separate words in a variable are named with capital letters. It's kind of anybody, it's up to your own decision what you want to do with the camel. But there is usually where you go to work, they'll have some kind of style guide or programming guide. So be prepared to adapt to meet with the rest of your team. And so once they get you those basics and get you up and running, then lesson 2 is all about operations. And, if you actually understand math pretty well, then all of this is pretty straightforward. Python's real easy about how it does math. All the sort of standard symbols that in most cases languages use. The plus and minus sign, obviously pretty straightforward. They use the slash for division and the asterisk for multiplication, the percent sign for modize operation, the remainder division, and of course then we have all these things like equal, equal. If we want to check if something is equal, then we use equal, equal. If we want to set something equal to something, we just use one equal sign. And then we can do all kinds of different mathematical operations. Excuse me. One of the things, if you remember from your math classes, is the I'm disabling the path link so I can have as much stuff on the path as possible. And that is all there was to it. It's a pretty straightforward install. And you've already got that done, so that's cool. So I'm going to minimize this out of the way. What I'm going to do is go ahead and kill this stuff, I guess, since we've done that real fast. And then I'm just going to, heck, I'm going to use PowerShell. What the heck? Technically, as we move into, his last part of that sort of first lesson is they show you how to basically be able to type into a command prompt and just get the Python interpreter running. In my case, I guess that's because it's going to be Python 3. Nope, I don't have the path set up yet is what the problem is. Ah, darn it. I see what's going on. So let me see if I can figure that out a different way. Let's see. I know that it's under app data, local. Oh, darn it. Programs, Python. So now if I type Python, I should, darn it, what the heck is going on? Oh, Python 36 again. Then we'll get into where the actual file is. There's Python. So now I can run Python. Normally, if you reboot, then it'll be part of your path. So you can just type Python on the other machine. I've got it set up. You don't have to go through digging all the way down to where it actually, but this is actually its own useful lesson. As you can see, we went all the way down into underneath your own user folder in a folder that's actually fairly critically important, app data. A lot of stuff gets hidden in Windows under app data. You'll see under local program and then Python 3632. Finally, we got to the Python executable. That's a classic path lesson. If you don't have the search path defined, and I've told it during the install to add Python to the path, but I guess I need to reboot before that takes effect. And otherwise, you have to be in the right place or provide all that pathing information. But once you get the interpreter up and running, you can actually do a whole lot of stuff. They take you on into setting up the VS Code and using the interpreter that's tied in, the command prompt that's tied there. But we'll come back to that as we go on. So, like a few things just to show them here real fast. You can do basic commands in here, including one of the things they showed us is doing a classic. If you've ever done any programming, then you will have done this multiple times, which is to basically write your first little hello world program to make sure that you know that you can do things. That actually is, I'm curious about, do you have some programming experience, James, or have you just been doing some
Actually, before I started this, I did a little bit of a intro Python. I didn't get very far. Like some of the stuff now that I'm seeing in lesson 3 is stuff that I haven't run into. The first 2 lessons was stuff that I had all done.
Okay, that makes sense. That makes sense to me. You just had a little bit, plus there's a little bit of variables and things like that talked about in that shell scripting back in system administration class as well. And, at the end of the day, that's one thing about it. I'll tell you this much. This class, I think, will get you a pretty good solid, understanding of a language. And then one of the things that I always teach people and tell people when I teach programming, whatever the language is while you're obviously learning Python in this case for this class, that those things that if you even go think back to that, those main things, every language has a syntax, every language supports variables, every language supports some kind of flow control. And then so once you get sort of the programming logic in your head with one language, the ability to move to another, is actually quite easy. It makes it quite easy to pick up another language. You just have to learn, okay, what are its keywords? How do I denote this? How do they code things? Do they use brackets? Do they use colons? Do they put commas here? Once you get the sort of syntax of each new language down, then it actually makes it very easy. And it's useful, you're going to have learned and been exposed to 3 of actually the 4 possible languages they test you on even beyond Security Plus, but the next coming test, which is called Pen Test Plus, that they were wanting you to at least be somewhat familiar with Bash, PowerShell, Ruby, and Python. And so the only one we don't have right now is Ruby, but Ruby's really easy to pick up once you have one down. So the interpreter, they have you do a few things in the interpreter in that first lesson, and then they have you write your first sort of hello.py file in the VS Code editor. I'm going to do all my examples in this case just through the interpreter as I go through. And so just to finish up then, as that kind of finishes up one for all practical purposes, except for if then, but we'll come back to some examples in a minute. And you said you were pretty comfortable with that. The one thing that's real important besides all those different operators and is a couple other is the one topic of PEMDAS, right? Parentheses, exponential, multiplication, division, addition, subtraction. Basically, it's the order of operations. And so just like in math, you would get different answers if you didn't do that right. If you didn't put the parentheses where you needed to, you got to think that same kind of logic when you're doing the math inside of your programming. And if you want to control it, then put parentheses around things and make this part happen before that part. And then, of course, if there's an equal tie, they'll go left to right. And you can keep that in mind, or once again, override that with parentheses as you need to. The only other thing, which funny enough, we'll talk about a little bit later, especially next week, is there's a bunch of methods. They talk about strings and string concatenation, where you can not only use the plus sign to be in a mathematical operator and add two numbers together, like we could do print, 2 plus 3 or 4, whatever I happen to type, and we get 6. But if we actually want to concatenate things together, then we can also use the plus sign to add strings together or put strings and variables together to have a dynamic output. And so that's sort of how 2 wraps up. And so then with that, we now get into stuff that you're saying is new to you or newer to you. And actually, I'm not totally surprised, but they use a little bit different naming, and I do want to point this out. The next 2 chapters are on list, right? List and loops. And there's actually a chapter on what they call dictionaries, okay? Well, before we go on, I think if you've gotten through, and I kind of skipped over it, but you got to understand, or I'm gonna close out so I clear my environment here real fast. I'm just using the exit command to get out, and then I'm just going to hit my up arrow and get back into Python. So before we get into list, though, do you understand well the concept of what a variable does in a program?
Yeah.
Okay. So we can sort of hit a couple things real fast. If I say do something like, I'm going to say test is equal to, syntax error. There we go. Great. I was trying to hit the quotes, my name, and then I'm going to say print, make it a string, hello, as an extra space there because I want that. And then I'm going to use the plus sign as concatenation. And you see what I've done here is I've combined now a variable with some string, right? But then when the output will come out, hello, Lee. Well,
yeah.
So if you understand a variable, actually, I hope this will make it easy for you. But a list is really nothing but a compound variable. And a dictionary is nothing more than just a little bit more complex version of a variable. And basically, the word that you may have run into, and that if you play with other languages, you're going to see instead of list in dictionary is what's called an array. Okay? And
okay.
So when you think of it, whether you think of it as list or array, it doesn't really matter. When you think of a variable, test is now been assigned to the string value of Lee, right? So we know that variable is equal to Lee. But
right.
If we want to do a list, all a list is just basically, I think they use it because it's kind of counterintuitive, but all I used to use it everywhere around, I don't know. I talk about how all an array is just a list of individual variables. So if you kind of flip that, that's all a list is you're taking individual variables and you're giving them a name that represents that whole list. And then you have multiple ways to access the individual values. So for example, if we one of the examples I think from the class is to create a list that's like countries, right? So we define a variable name. It's still going to be a variable. In this case, it's going to be a list. And we use these brackets, right, to separate it. And so we could have USA. And since these are going to be strings, we put commas around them. And then we put single quotes or double quotes, whichever you need. Comma to separate the value. So we would then say have Canada. Oh, I keep hitting the enter key instead of the quote. Hopefully they let me hit the up arrow and repeat. And then I guess we can throw one more in here, Mexico, and close that list. Now, we have created a variable named country that actually holds 3 values now, doesn't it? It holds a list. But so how do we reference one of those individual items? Well, like I said, a list is the same thing as an array, and basically, what that they're organized by an indexed value. And since computers like zeros and ones, they start from 0. Basically, each of these items is representable by an index. So the first value is 0. The second value is 1. The third value is 3. So in principle, what we should be able to do, besides my selecting all over the place, is we should be able to do something like this. Print and you see what I did there? Now I'm able to actually print one of those values out. But of course, usually we're not, I mean, we might do that occasionally, but more likely what we're going to do is iterate over the list, right? We're going to go over the list and do something. So we could write a command like this, which is one of the loops that we've talked about, like a for. So we could say for country, 1 in, oops, my space bar is still acting up because it has all semester, in countries. And then this is one of the key things about, they don't use brackets around things or semicolons. They use the colon to represent,
Starting a new.
Whoa, sorry about that.
Starting a new line in the same function.
Yeah, so this basically says, okay, this is one line of code, colon. This is starting our for loop. And then you'll even see, and it's something they talk about in the chapter as well, about indentation. So everything that you want to have happen underneath here, they're actually, those dot, dot, dots aren't the indentation. They're telling you you need to. So I'm going to hit the tab key, and then I'm going to say print country. And then if I wanted to do other things, I would tab and have more commands here. But in this case, I'm just going to hit enter. And you see what happens is it basically does that for loop. It creates a variable called country. And then for each of the items in that list called countries, it basically fills in and it goes through each time. First time it says, okay, the 01, USA, and it prints it. And it goes back through and gets the next country, which is the 1 value. But the way you reference them is that previous example, like when I wanted to print just 1 country. So anytime you create a variable that's just a single variable, like test is equal to Lee, then it's only got 1 value. But when you create a list or an array, you are having multiple comma separated values, and every one of them are indexed by a number, and it's just an order. So it starts at 0. So the first value is actually 0. The next value is 1 and 2 and 3. And you'll see, for example, instead of just doing for country in, sometimes, you may want to process over so many items in a list. And so you might use a for 1, x equal to 1 plus 1, and then until it hits 5 or something, you set your condition up so you only loop 5 times, and you only end up touching the first the first 5 elements in a list. But you can reference them anytime you want to by basically pulling up, by each one has an index value, and if you end up with a list that has 1,000 items, then it's going to be a 0 all the way to 999. You see what I mean? And every individual value is referenceable. But because you have these ability to do these loops, we can process over that kind of information. And the one thing, they also talk about something that's called tuples. I guess I'm pronouncing this right. I've actually never heard this term before outside of Python. But basically, it's just a list that instead of in square brackets, you put in parentheses. And basically, it's an immutable list, so you can't technically change it. So if you were going to have, some hard-coded stuff that you didn't want even by somebody changing by some other dynamic programming later, or be able to input and overwrite, you could put those in that list, and then it works just like any other list. You reference the first value with a 0 index, the second with a 1 and 2, count on from there. You can loop and do anything you want to with them. So lists are just collection. It's basically one name represents a whole series of items. But then you use the bracket in that number to represent any particular individual value. And of course, the real reason that people use lists is to be able to, to loop over them and process over a whole series of transactions, for example. But we could update the values, like we could actually change the value of one of those values to, if we had made a mistake or something. And there's a couple different ways we could go about that. But the truples would, of course, be immutable. You wouldn't be able to actually go about that. Now, the other thing is, besides the for loop, is the while loop. I kind of skipped over them because you said you were trying to get to three quick, but do you get the basic if then else kind of logic that goes on?
Oh yeah. Okay. Yeah.
That's actually real key. Between these two, almost like I said, every language has some form of if else, then, whatever, if then, some kind of logic, however they structure, and whether they put brackets or quotes or colon at the end of the line and tab or whatever to denote the syntax. And then every language usually has some form of loops. The Python folk has, for and while, but there's also other languages might have a do while, and they're really just variations of a theme. Some of, one of the loops, depending on how you set up the conditions, you can determine. Sometimes you want to make sure that it happens, the loop will go through at least one time. And then sometimes unless the condition happens, you don't want the loop to happen at all. And so you can set up your conditions, because all of this is, if some value is bigger. Like a good example I like to use is, like, imagine that you were writing the code for an accounting app, a little module of it that was going to calculate the bonus, right? And so if the bonus was, you got so much % of sales for sales over $1,000, then you would load up, your program would go and maybe pull from a database all of the sales transactions for that salesperson based on sales ID or whatever last month, and then put them into a list, and then say, for each sale in sales, if it's over $1,000, times it by 2% and add that to bonus total, and then loop again. And so every one of the values that was not over 1,000 wouldn't be considered for bonus, and the other ones would. And by the time you got through at the end of that looping process, you'd have the total bonus for that person, which then you could, put on their check or whatever the case is. So we control, as programmers, the logic. A lot of the simpler scripts and things, we might want to, for example, if we were writing a script to iterate over, we might have a list of all the IPs of our servers out in the DNS, out in our DMZ, and then we're going to use, say, nmap, right? We're going to feed the script, and we're going to basically run nmap, passing in just, for whatever, we have 10 servers out there and we have 10 IPs in our thing. So we're going to say we can set it up so that we have basically, set up a starting value of 0 and use that as a variable inside of that array. And then each time we pass through, we increment that variable one and come back through again. And then we could run nmap and just have it scan all of our servers for us without us having to type it in each time individually. So between the flow control of if else in this case, or the for and while loops, we can pretty much, control completely where we go within a program. And that's the way most things work, even like a login, right? If the username and password match something back here in the database, then let them in. If not, throw an error, right? So a lot of functionality in programming is just if then, and then a little bit of looping over things as you need to repeat task again and again. So any questions on the loops there, or the array? Either one, the list or the loops, I guess I should say. Does that make
no, not really. Yeah, it makes sense.
Yeah, so like I said, if you understand variables, then it's just an array of variables, basically. It's a grouping of variables. It still has one name, but if you want to reference an individual, you use the square brackets and whatever an underlying number is needed. And the tuple is just a list that you can't change. So what is a dictionary then? That takes us into for, right? Well, dictionaries are, once again, this is a kind of unique Python language. Once again, usually other languages would refer to a list as what they call an indexed array, because it's got an index value, 0 through whatever. And then they work exactly like, if you hear that phrase, index array, in some of their language, oh, that's a Python list. Well, a Python dictionary is what's called a named array. And the idea is that instead of just storing one value like we did, country, so we had US there, we have Canada, we have Mexico, we're going to store pairs, name and value pairs. And this way, basically, instead of being able to reference, sorry, I'm hearing some noises. I don't know if the neighbor's working next door or something. Sorry, it's just distracting me.
Oh, I didn't realize that was from yours. I thought it was something around here.
You hear the sound of rustle or noise or something? Yeah,
Yeah.
I think that's from my end. It seems like something's going on. I'm not exactly sure. Maybe somebody, a neighbor, working in their yard or something. I just hear almost. Anyway, as long as it doesn't get too loud, we'll keep on with our lesson here. But what dictionary do is they allow you to have name value pairs or key value pairs, as Python refers to them. And so then in many ways, these are easier to deal with when it comes to memory and code readability, because if you write some issues in a list and then you do a bunch of references like we did there with print country 2, what does that tell anybody? What is that going on? They'd have to go back and find the list and figure out. And if that was print country 2000, that would be a huge list up there that to try to figure out what's going on. But when you set up dictionaries, you're actually saying something like, I want to set up, like an employee database or whatever, and I'm going to store information in there, and I'm going to store a name and a value. So I'm going to have like first name Lee, last name McWhorter, and I'm going to store both of those. Then when I come back and reference them, I reference them by the key, and I get the value. So it's sort of, if I do this right in here, actually, let me do this again. I'm going to exit, and it's just a methods, a function. So I'll put the parentheses, get back in so it clears my environment variables again. And so if we do something like, I'll just pretend it's employee for whatever reason, employee is equal to, now in the case of, once again, with variables, we just, if this was a standalone variable, we would just either have a string or we'd have a number or whatever, like a true or false, like a Boolean, we'd have that in there. In the list format, we'd use the square brackets and we'd comma separate everything. In this one, we're going to use the curly brackets to do a dictionary. And then let's say we're going to do the one I'm doing where we're going to pretend, if I can hit the right keys, there we go. So we're going to have name, and then we use a colon to separate. And so then my name is Lee. And maybe I'll just put my whole name in there. What the heck? We could have had, a first and a last name fields, but I'm going to keep it simple. And so then we might have, and so the comma then separates another one. And then I'm going to say title, like my job title, colon, instructor. And of course, we could keep going on and on and on with that. I'm just going to do a couple of them so you get the basics. So now we've put that in there. So how do we reference some of those individual values? Well, actually, it's just like before, except that we use, so like we would use a print, and we would say we want to print employee. And this is one, I think it's like this. I could have this. Oops. Okay, so I'm wrong about that. It must be. Oh, Karsh, what am I doing wrong here?
Wrong bracket.
Do I have the wrong brackets?
Maybe.
That's what I thought. But the idea is that you, just like we use the reference of a number, the index, we use the reference of the actual of the actual key. And of course, I may be doing it. I work with so many languages, I get confused. Is it this model? Nope. I'll have to double check that in just a second because I'm just spacing here as I had worked through most of this. I think I said, so it did, yeah, it didn't throw a fit about, it's not liking the name I'm trying to use in that context. So I'm messing up how to do that one. And it's telling me the dictionary object has no attribute name, but it does because we define name. So hang on a second. I'm gonna go ahead.
Is it possible you don't need to put the quotations around that?
Yeah, it absolutely is. I'm not 100% sure what I'm doing wrong there, so I was double checking real fast here because I thought. Let's see. What did I end up being? I was going to double check. Okay, this isn't the right account. What the heck? Oh, my God.
I can't look on the lesson because I'm not that far yet. Because it don't let you move on until you finish it.
Yeah, I'm I may have it here actually. Apparently I don't. Hang on one second. Darn it, my bad. I logged in the wrong way here.
Oh.
I'm still gonna remember my login.
It's like the worst thing for me trying to remember all my logins for stuff.
Ah, there we go. I'm trying to figure out how to log out of this one. I don't ever do this very often now. I know what happened there. Okay. Yeah, I know what. Yeah, yours. My gosh, I have so many logins. It is unreal. There we go. That's the one I wanted. I have a instructor login, then I have a test student login. So I logged into the wrong one.
Oh.
That's not what I want. That doesn't have the right stuff. So let me double check this for us because I'm just messing up. That's the way computers are, aren't they? They completely all it takes is one character. So what I'm supposed to do? Oh, darn it. That's what I did. Okay, here we go. Hang on a second. So let me bring this back. Let me come back to here. May I see what I did wrong? Hold on. Oh, I messed that up. All right, so this is what it should look like once I get my cursor back in here. It was actually the very first version, but what I forgot to do was put single quotes around it because it's a string. There we go. You see how that works? So
Yep.
the idea is all we're doing is we curate our own values. And that way, then we can reference those later. And of course, that makes things, a lot easier. Employee name, employee age, employee title, employee salary. When you're reading the code and you're referencing it, it makes it a lot easier to troubleshoot, debug, etc. than employee O, employee 3. You see what I mean? So the index thing, they're actually, once again, though, they're just variables, okay? I mean, a variable can have one single value. A variable can have a list of values, and you reference them by the number. Or a variable can hold a whole array of named key-value pairs, and you define those. And so in this case, this allows us to be able to access any of those. And, of course, if we change that just to change the title part, then we would get instructor, right? So the idea is that we can reference those, and we could then, we might pull in a whole bunch of data in a sense, like doing a SQL query, right? We get the title, we get the name, the key part from the field, right? First name, last name, city, state, zip, and then we pick the other value and put it into the value part and create our memory array. And then we might only need to print out later on, welcome Lee, your most current balance is, you know what I mean? But we may have pulled that data from a database. And this allows us to have much more readable code. And then the other thing is that you'll see that people will create arrays to just, a lot of mathematical reasons to do so. As a matter of fact, one of the add-ons we'll talk about, I believe, it may be in the later next week, but we'll talk about adding modules and add-on packages in. And one of the ones we talk about allows you to have what's called an n-dimensional array. So here we've taken an array, and now we're going to have this, but that way we're not going to, it's going to be more index-based, but it's almost like 3D chess. You can fill it with whatever data you want and whatever, and then you can write your analysis to do major scientific data science type of analysis. We're not going to have to do that kind of stuff in security generally. But using once again, we might pull in, data or have set up an array, a dictionary, if I use the right Python term, that has, once again, instead of just like the list before that has the IPs of our servers, maybe we have the names and IPs of our servers, or we even have a login information because we want our script to build a login and check the free disk space and then come back and report those, So we're going to mainly, and even Python, while we're teaching you to program, we're not expecting that out of this program you're going to write the next game. But if you do great, remember me when you make the big hit. But we are expecting that you'll be able to potentially write scripts that automate tasks, automate security or system administration type tasks. And the way that they're going to expect you on, say, some of the certification tests is they're going to expect you to be able to interpret a script and at least sort of read it and understand what it would do, kind of thing. So That is dictionaries. Let me see if I'm missing anything about it. There is one other thing that they talk about, which is there is this. I'm not going to do a version of it, but you can, instead of doing the parentheses, the curly brackets, and all that, you can actually. I'm not sure in a sense why it matters, but they have a function called dict that starts a dictionary, and then it has its own. And what you basically then is just feed it the name value pairs. And so you would say like new dictionary equals dict. So it's a function you're using that's already pre-canned. And whether any need to do that version versus another, there are a number of things that you can do with regard to these. You can find out. You can have it come back and give you just the key values, or have it give you just the values. You can obviously go to a particular thing. Since you may have pulled this from a database and not know how big your dictionary is, you can figure out the length of it, what is the number of objects that are in there, etc. But those are things, once again, that, to be honest, I don't really see, a lot of the type of script work we're going to do. I'm not saying don't learn it, but it's not as important as sort of the basics of flow control. You might use a list or a dictionary, but you're probably not going to use it in a very, very complex way, at least with the scripts you would probably write at this level. So, and then of course, once again, we use looping many times to process through this, right? And we can loop through all of it, or loop through the values or just the keys. One of the things that they then kind of okay, let's add more complexity to it, but they talk about something at the very end of that lesson called nested list or nested dictionaries. And that seems complex, but really it just means that, okay, like for example, we had that we have that one up here. We created just a list, right? Countries. And we had USA, Canada, and Mexico. But the problem was that's only 3, right? Like, so maybe instead of doing that, we have North America is equal to US, Canada, and Mexico. And then we have South America is equal to a list of countries. And then something else is equal, Africa is equal to a list of countries. And then we can put all of those lists into another list.
Okay.
So countries would hold North America, South America, etc. But in other words, they're holding a list themselves. You can make it so just like a variable can hold anything, including a list. Well, any individual data point it can be another list. So you just nest list, and then you end up having to reference something like, if you wanted to get one particular country out of that kind of a combo, you would say, okay, I want country 0 to be the first index, and say that's North America, and then North America 2 to get Canada or Mexico out, or whatever. You have a nested set of lists.
Yeah, I get what you're saying there.
Once again, it's whether you ever need to use that kind of a data structure, it's something to be aware of and know how it works. But unless you get into more complex programming, one of the things that many times these very complex lists might be. Do you do any gaming, James?
Yes.
Okay, good. I'm a big gamer myself, so I like to use gaming examples where I can, because I know a lot of times the students can relate.
Yeah.
But like, if you play a massively online multiplayer game, like I've been a big fan of for the years, you zone in to a new zone, right? In the background, even though you can only see so far given the fog of war of your game, your client knows what's on the other side of that zone because it got all the data, all the spawn points, right? It got all the monsters. So that's why when you walk over there, you don't have to wait for a second for it to load up. It just draws the graphics. As soon as you come around the corner from that mountain, you see the dragon, or he's in that cave. But as soon as you log into the zone, the server sends you all the state of that zone. And it says, and basically it's going to end up being this huge array in your program's memory of ID for the monster, spawn location, XY coordinates and Z coordinates, things like that. And then, of course, it actually, of course, is more complex because it tells you that if you zone in, you know where everything is. But, of course, if there are other players, they're moving, right? So that's what's being dynamically changed. And, of course, if a monster is like a path pattern, padding around, then that information has to be, changed. But all the static points, where every tree is, where everything is, is in your system. It's in your memory. And most of the time, that's basically stored in a list or stored in an array. Your inventory is a list, and that might be a list inside of the list that is your whole character, right? That tells everything about your character, your attributes, your spells, your skills. So your character is a list of lists. That makes sense? So that's exactly all, embedded list is, or nested list. And Well, good. That you're a gamer, that's cool, because I've got some really good gaming analogies when we get into object-oriented programming, too. I learned a lot of this building an EverQuest emulator years ago that I have running here in my house. So let's see. I think that's everything on dictionaries. Do you have any other questions?
No.
Here's your list. Okay, so that's 3 and 4. I'm just checking all my notes. So we got through 1, 2, 3, and 4. So that leaves us then to talk about functions, right? Okay, functions, if in a way, if you think about it, if you've got the idea that a variable or can be, a value, a name, a whole big long number, or it can now be a list. It can be a name key value list, or it can be list of list. Variables can hold all kinds of data. And by being able to have these data structures that we can hold this variable, it makes things so much easier. I mean, obviously, things like Facebook couldn't exist without variables in programming languages. If Facebook had to go and put an if-then into their login every time somebody signed up for their site, and they have 1 billion users, and it had to go through a series of if-thens, 1 billion lines long to get to your new login and say, oh, yeah, you match. Okay, I'll let you in. Then that code just to log in would be, gigabytes, and it would take an hour to log in, right? But instead, they probably have 5 lines of code, because as soon as you type in your username and password, those get put into variables, username and password inside, and then they run, if username equals that, and that's their code is so small because they don't have to worry about every possible combination of username and password. They can use the variable. Well, and we can, if we need more complex variables, we can use lists and dictionaries and all that wonderful stuff. So what are functions? Well, functions basically are a way to group up commands so we can reuse them. The course uses this dry analogy. Do not repeat yourself, basically. Don't repeat yourself. And in programming, we really don't want to. If we can help it, we want to. And I'm a big proponent of modular programming, whether you do it in kind of what we're learning here, what they call procedural type programming, kind of step by step. Even then, you want to be able to repeat, like I'm going to be able to use this code again. And if I can break it off into a separate little file, then I can use that by just importing it in. And so we can create functions that instead of having to write the same line of code 6 times, every time we want it to output that greeting message, we can write a function. And then when we write the function once, then we just have to call that function later to get that functionality to come out. And so functions are a common thing. Every programming language has some way to define and declare a function. In Python, you do it with the def for define statement. And so I'm going to, I think I can get away with this without the other stuff in there. So I'm going to define one called greeting, right? Now, when you define your own function, functions are methods, and we'll talk about that next week and really separate them. I mean, they're really 2 sides of the same coin. It's just a matter of whether you're doing kind of old school programming or object-oriented new programming. Functions and methods are the same thing. But they have some parameters sometimes, right? Like you may need to pass in something. Like the login function, you would need to pass in a username and password, right? In our case, we don't have to pass anything, so we're just going to close the parentheses. But if we needed to get variables, and technically I could use it, like I could say I need to get a name so I can greet somebody. And I think there's an example in the chapter that takes this a little further and does that. But I'm going to say that I'm defining this greeting. And the one thing I'll tell you is that this semicolon line ends up being at the end of if statements, while statements, definition statements, but then almost every other statement doesn't need anything, right? Besides maybe some indenting. Then once again, what do we want it to do at this point? Well, I'm going to tab in, and I'm going to say this is print. And I know these are simple examples, but still, they serve to illustrate at least. So, and then when I hit enter again, back at the prompt, nothing happened. Well, I haven't done anything except define my function. My function that just like print is a function. It's a built-in function, right? Some of these other functions and methods are built in, but we can build our own. And so in this case, I've created one called greeting, and now all I have to do is run it. And then I get that code. So obviously that's a simple example. I could have typed print hello world as fast. But once again, if I needed to have a function that was, like a login function, I would define login, and then I would basically, have it take the input from the web page, put them into variables called username, password, go do the database lookup to make sure they exist. If they do, redirect them to the success. If not, throw the error. And then every time somebody, like even if they get logged out by timeout, I'm going to return them. I don't have to write that code again. I just call login again, right? And then that whole series of block of code will function for me. And so that's all a function is. There is one thing that the way I did this one, it works. You don't have to have it, but most of the time, and I'm doing everything here at the interpreter. So like, you get the hashtags for comments and things like that if you're actually writing code. But in this definition, like if I do a separate one, let's do another one. We'll say greeting to. Hit the right keys, McCorder. We're going to say, now generally they want something called a doc string, which uses 3 quotation marks. And it's basically a comment within a function. This function presents a greeting.
Yeah, I've done those.
Yeah, and then so 3 quotes, and then we tab again, and then we say our print. Oops, I forgot my quotes, didn't I? Thankfully, we can edit. And then if we call greeting to, we get that one to run, right? So that was one step. It's not a required element, obviously, to function, but once again, for readability, using comments, I always tell people comment your code. I mean, you're documenting what this does. So if you've got some fancy algorithm, you come up to do the math, you explain, because what's going to happen is, even if it's not you, but it's going to be you. It's happened to me. I used to not be so good at documenting code. And then 6 years later, I got to go back for some client for an app and go, oh crap, what did I do here? And I'm having to write it out on paper and figure out exactly what the math is when I could have just written myself a nice little note. This takes this value, divides by this, and calculates that. Oh, great. That would have been so easy. I wish I'd have taken the time. So nonetheless, that's one of the things that's what the doc string does, is sort of comment a function. And so if you need a function to take parameters, then when you define the function, you define what parameters it's going to take. And as they talk about, when the function gets called, and actually then, you pass in something to be that parameter, that's what's called an argument. You're sending the argument that's going to end up going into, and basically it's just a variable in a sense, right? You're passing in a value you want the script to use, the little function to use. And of course you can write functions inside of one py file, but what happens, and that's where some of the ones, some of the built-in ones are basically in another file somewhere on the system that you just don't even know. You call it, but it's already default included. You can actually write your own py files that are nothing but a whole bunch of functions, maybe common functions you use anytime you do XYZ type of project. And so one of your first lines in your new project will be import myfunction.py. And then all those functions you can just call by saying greeting to, sales tax calc to, whatever they are. And you've already written all that code over here. And so when we get to it, like I said, at the end of the day, what we're going to see next week when we get into the second part and we start diving into the object-oriented, what we've sort of done up to here is what's called procedural programming, where you're the code just kind of flows down through. Now with functions, of course, you can have an if-then call something and repeats code that's a function you define. And so many times that's what you'll see is a more complex program would have maybe an import line or two bringing in some of those functions or other modules that it's adding. It would then have functions that were just defined for use in this program. And then you would then start to have your main, steps of your program, and then ifs and whiles and whatever. And then you can loop back to things. Did you ever program in the old like BASIC by any chance?
No.
Okay. I kind of miss those days. That's how I taught myself to program on a little Commodore computer years and years ago. But you had to label this will, of course, will complete errors. I'm just going to show you the example of it. So you would have something like 10 print lead. Of course, it's going to throw an error because these aren't valid commands. And then you'd have 20 go to 10, and you'd have a repetitive loop that would just basically print lead across the screen. And so this is very procedural driven. That it kind of goes down, but of course you could have a statement here that takes you back up and it repeats. But it's still procedural. It's sequence based. However you want, process based. And then the other model we'll talk about next week is what's called object oriented program. one thing that helped me is to actually learn. It took a while, but to learn that things like functions and variables that are so common and everybody gets, or most people get when they start getting into programming over here, they get called something different in object oriented, and you think it's a whole new thing, but it really isn't. So when you hear the word function, like we created that greeting function, or you hear the word method, which the text references without defining early on, and it does later. But that is a method is just a function that's associated with an object. It's just a function. And when you hear about attribute or a field of an object, that's just a variable of an object. Once you understand that, then all of a sudden it's just two different mindsets. Either I'm going to kind of go stepwise programming, or I'm going to do it with this object-oriented model. And I'll try to explain that better and use some good gaming analogies for you next week as we get into object-oriented. There are a couple things that I guess I'll just throw in. There's the break command. Of course, there's all kinds of special keywords, various statements like that. And there's one thing to keep to hit on before we run out of time here today, James. But and that's the concept of scope. Are you familiar with that or heard of that before?
No, I haven't.
Okay. This is an important concept. Almost every language supports scope and demands and forces scope, if you will. So, like, here, for example, I created a variable earlier that test was equal to leave, right? And then when I told it to print test, it printed it. Okay, cool. Well, let's say, and then, of course, now I've also created this function greeting. Well, actually, this might work if I do it this way. Let's do this. I'm going to do another one. Define greeting 3. Okay, so now in this case, I'm not going to worry about the doc string. I'm going to say message equals tabbing again, keeping them together so they're blocked, right? Because they're both going to happen under this function. So then I'm going to say print message. Now, once again, I've defined, right? I've defined this function. So if I call the function, we know it'll work, my message, right? But inside of that function, I created a variable, didn't I?
Yeah.
So what happens if I do this? Now, why didn't that work?
The indentation makes it part of just the function. It's not a separately defined.
You've got it, James. That's it. That variable only lives in the local scope of that function.
Okay.
That's why we even have a return statement, because we might want to send something like that bonus calculation function. So we pass in the salesman cells, and then it does the calculation, but we're not going to be able to get access to that number. So we're going to have to return a value back. But the stuff that's inside of a function lives within, that's called local scope. If you want something to be global, you have to use the global keyword, or it has to be defined outside of the function. So yeah, you had it. That's what scope is. So anyway, that's all there is.
Okay. I guess I just not heard it described as that before.
Yeah, that's actually, it's a very common programming context, but yeah, it makes sense, and I'm glad you grabbed it, because it's one of those things that sometimes people go, hold it, why didn't that print out? And that's what's getting them, is that they define the variable inside of a function and they can't use it elsewhere without some other way of passing that or setting another global variable and using the function to change the global variable. But variables that are outside of function definitions are global by default in Python, and stuff inside is local scope. So that's an important concept. And I think those are the main ones. I saw you were blowing through the first couple quizzes and you've gotten through the first couple units. If you have any questions, fire away. This is my last class, so I'll stick with you as long as you want to. But we'll cover the last 5 lessons next week, where we'll be getting into object-oriented programming. It kind of splits nicely. It kind of gives you the basics of kind of the old school procedural programming, which is closer to scripting, say, just steps at a time, a little bit of flow control in there, do what you need to do. And then we are going to give you an introduction to object-oriented and explain that next week.
All right.
Okay.
Yeah.
So any other questions tonight, James?
No, not really.
Well, I appreciate you making it. James, you are the farthest along student right now. One of the early ones that it's just kept plugging along. And
trying. Sometimes I sit here and I'm a little frustrated working through stuff, Just because a lot of time it's just like there's a lot of it you got to do and stay focused on, and sometimes that's the tough part. Is
Yeah,
just staying with it.
absolutely. It's one of the things you may have heard me mention in some of the earlier classes, and I definitely do in some of like I did it to mention it today in networking foundations to that group, the new group that's coming up. I was like, stay focused. Don't be running 6 things in the background. These are pretty big, intensive things, and you need to focus. Computers are very picky. One space, one like the quotes I missed earlier, and everything breaks, right? And
Oh yeah, yeah.
so you just space for a moment. So and there is a lot of material, but I've seen you use the channel, and of course, talk to Joy or talk to me. Glad to see you in class. I've done most of these as more just video lectures. I'm hoping we'll have more and more people as the program keeps growing. And I'm glad that this was even a case that you could make it and that it was helpful for you.
Yeah, I actually had just thought about it. I'm like, hey, what time was that listing this week? I might be able to make that one. And I checked, and it's like, oh, like 10 minutes.
Yeah, you jumped in. I saw you there, and I was hoping you were going to still be there. I wanted to start it on time, for the recording and all the other reasons. But thanks for showing, and thanks for your questions. And let me know if you have any other. You can Slack me anytime. I have it set up to ping my phone if I get a direct message. I check the channel every so often, try to stay in at certain times.
Yeah.
I'll get this posted, of course, if you need to review it later tonight. Hopefully this will help you put those new lessons in place and let you keep cranking along.
All right. Thank you.
Thank you. You have a good evening, sir. We'll talk to you next week.
You too.
Thanks. Bye.
Bye.
Stop my share and